Hello everyone, I am Siddharthan. In this video, we are going to discuss about one of the interesting topics in generative AI and retrieval augmented generation, and that is about Route LLM. Let's say the user asks questions like summarize a given document, or they are asking questions on specific piece of the document. Let's say that we have this attention is all you need paper in the PDF format, and the user is asking question on explain about this particular architecture given in this document. So basically, we have two types of questions. One is like general summarization, and the other one is like a RAG based question or document question answering thing. So here we will build a Route LLM system which will have two flows. One is summarization flow, and the other one is RAG flow. So based on the user's question, the LLM will make a decision on which flow it needs to take, and based on that, we either go to the summarization flow and the RAG flow. So similarly, you can build it like for other use cases as well, not just for summary and RAG, but you can use this for other routing as well. But this is the simple use case that we will be considering. So this will be the agenda for today's video, and let's get started. So these are the libraries that we need. So for this, we'll be using Llama Index library. So here I've did this pip install for Llama Index, Llama Index LLM Llama. So if you want to keep the LLM local, you can use some Llama models. And for that, you can install this extension of Llama Index library known as Llama Index LLM Llama. So here I'll be using Llama Index LLM's Groq. But again, if you have a bigger GPU where you can, pull in Llama 3 models or something, you can go with Llama. So if you don't have much GPU power, you can then go with Groq. And then you have Llama Index embeddings Hugging Face. This is basically to kind of build those vector embeddings so that we can kind of integrate it with our RAG Q&A. So these are the libraries that we need. So this I've already installed this. I'm just going to comment all these things and run this again. So but when you are running this for the first time, you can install these libraries. If the libraries are updated, you can also update these specific library versions and just like install these things. So the main purpose of doing this is, right, so you the summary questions are not answered properly when you put that in a RAG chain, and then again similarly when you put something on RAG Q&A on summarization, it won't work, right? So that's the main reason that we are having these two things separately. So let's see how we can implement this. So the first thing I'm going to do is import OS, because we need this Groq API key in order to call this Groq model. So we will save this API key in the environment variables using this OS. If you are using Llama models, then you probably don't need this as well. The other important thing, and this is like kind of specific to Llama Index, is that we have to use nest async IO. So here I'll say import nest async IO and say nest async IO dot apply. This is a very important aspect when you're using Llama Index. So basically, asynchronous operations are those which kind of run parallelly with other operations. So let's say that there are a set of tasks, and in some cases, let's say task 2 has to run after task 1 has completed, and task 3 has to run after task 2 has completed. So this is what we call as synchronous operation. But asynchronous is like when we kind of try to run things parallelly or simultaneously. And we kind of need this in the case of Llama Index because we have several aspects. So we have this network calling part, we have this input that we need to feed and all those things. So it kind of depends on these asynchronous operations. So we need to enable this to the program so that it can run multiple asynchronous operations. So this Nest Async IO, which is inbuilt library in Python, would allow you to do that. So you need to run these particular code. So this we don't have to install this in the pip install, as kind of this comes as a standard installation with Python as well. So this is the next simple step. And now I'm going to say from llama index, llama underscore index dot core import simple directory reader. So I'm going to use this in order to read the PDF file and kind of like, load this data, extract it, and let's say later we would convert it to vector embedding. So I'll import this. So from llama index dot core import simple directory reader. And the document that we will be using in this case is this attention is all you need paper in this particular PDF, which is about this, paper that's kind of released about LLMs and all those stuffs, basically about the transformer models. So we have imported it, and then we have to pass this PDF to this simple directory reader. This again works when you have multiple PDFs as well, but I'm just kind of going to stick with this one PDF alone. So this would work for that multi-doc QA as well. So in the next step, we need to load the document. So in this cell, I'll just write a comment and say load the document. And let's create a variable called as documents. So documents is equal to simple directory reader, and within this parenthesis, say input files is equal to. If you have multiple files, you can mention all those things, or you can also write this code in such a way that all PDF files would be kind of read. So my notebook and this PDF are in the same directory, so I can just say, like, mention the name of this PDF that I'm working with. So I'll just click on rename, and just like copy this entire name and paste it over here. So this should be pasted within this particular list within this codes. So this is the file that I'm going to read, and outside this parenthesis I'm going to say dot load underscore data. Put open and close parenthesis here. So documents is equal to simple directory reader, and the parameter that we have to pass here is the name of the files that we are working on. So here we have only a single file, so I can just say attention is all you need .pdf, which is the name of the file, and say load data, and you can run this. So this will read this particular PDF and store all this text content into this variable called as documents. So if you want to dive deep into this particular variable, analyze like what's the data type and all those things, you can do that as well. So here I'll say print documents, or maybe first I'll try to show you the data type. So I'll say print type documents, and it says it is a class list. So it's a list data type. And I can also check the length of this by saying length of documents, as this is a list, and it says documents is 15. So now when I come back to this PDF and open this, it's you can see it has like 15 pages, right? So that's why we kind of have 15 elements in this particular list. So what this basically has is, if you just like print it like this, so first we have this metadata, you can look at it, and then we have page level. So each element of this list basically contains each page data. So first element is the first page content, and then if you just like move later, you have this page 3, page 2 would be somewhere here. Yeah, page 2, page 3, and so on. So we have 15 elements, which basically corresponds to those 15 pages that you have over here. So I'll comment this and run this, so that we are not seeing that large text over there. And again, if you want to print a specific element, let's say that we want to look at the first page content, say documents of 0, which is the first element, and then you would see this thing as the basically the first page's content. So we have page label 1 and all those content here. So if you want to look at specific page content, you can do that. Again, I'll comment this particular thing and run this again. Okay, so the next step is we have to split this document into chunks. As again, we would do this in any RAG application, right? Even if we work with LangChain, we would split this, using character text splitter or recursive text splitter with those chunk size, overlap size, and so on. So similarly, we have to split this into chunks. So for this, I'm going to say from Llama Index dot core dot node parser, node underscore parser, import sentence splitter. Okay, so basically it's going to split your document based on this sentence thing. So I'll run this. So let's say splitter. So here we are creating an instance of the sentence splitter. So I'll say splitter is equal to sentence splitter, and then we have to again mention the chunk size, chunk overlap, and all those things. Let's say that the chunk size that we are working with is, let's say, 2000, and maybe let's say we have this chunk overlap as 20 or something. Again, you can play around with these numbers, but again, and try to find which is your optimum number. But just for this particular demonstration, I'll just give this 2020, not specific decisions on like why I made this particular numbers and so on. So here we have the sentence splitter with this particular parameter stored in this variable called a splitter, and then we need to create these nodes. So again, which are basically the chunks that we would have in LangChain. So I'll say nodes is equal to splitter dot get nodes from documents. Okay, so here you have to pass the documents list that we have created. So first we read the documents and stored in this list called as documents, and later we are kind of passing this documents to the splitter dot get nodes from documents. So this will look at this document content and create like smaller chunks called as nodes, and that's stored in this variable called as nodes. So let's run this. And now this has kind of created all those nodes that we need. I mean, maybe if you want, you can just again check the data type of this nodes, and try to look what's present over there. So what's the length of the nodes and so on. So length of the nodes is, again, we have this 15 things. print this node. So we have this text node now, and this is basically what we currently have now. Okay, so I'll just remove this for now. Okay, so from this document list, we have created text nodes, which is our kind of code. So now I'll say from llama index dot core import settings, and then from llama index dot llms dot olama import Olama. So if you are using Olama, then you can import it. So I'm going to use Groq. So I'll comment this, but again, if you are using Olama, you can uncomment this and run. If I mean someone would be using Groq, right? So for search cases, we can say for sorry from llama underscore index dot llms dot Groq import Groq. Okay, so these are the two libraries that we have installed. We have Llama Index LLMs Olama and Llama Index LLMs Groq. So these are the two things that we need. And then from Llama Index dot embeddings dot Hugging Face. So we are going to use Hugging Face embeddings. So say Hugging Face embeddings embedding. So you can use different models, but I'll just like go with the default model that we have in Hugging Face embedding. So I'll run this. No model name LLMs dot index. Okay, so this should be LLMs. Let me run this as well to make sure that the code is running. So in the meantime, I'll show you how you can get the API key from the Groq. Okay, so this is completed. Okay, that can wait then. So here I'll say settings.llm is equal to Olama model is equal to, let's say, Gemma 2 billion is the model that we are using. So I've already made videos on how you can install Olama and how you can pull the models and kind of stuff like that. So once we have installed it, you can see the list of models using Olama list. That would give you the models that you have. So I currently have Gemma 2 billion, which is a smaller model, or you can also use like a Llama model, which is kind of slightly larger than this, the 8 billion model, but its performance is kind of slightly better. So you can try that. So yet Gemma 2 billion is the one that I have. So that's why I'm kind of mentioning that in this case, but I'm going to comment this because as I said, I'm not going to use Olama. Instead, I'm going to be using the Groq LLMs. So this is how you need to set up this. So let's say that now we want to set up Groq LLM. So for that, as I said earlier, you need the API key. So let's see how we can do that. So if you want Olama, just uncomment this and run this. You don't have to run the Groq part as you already have it. So here, go to Google and search for, I'll show this to you, Groq API key. I hope you have already created an account. You can just like create a simple account with your basically Google or Gmail ID. So it's like a pretty straightforward process. So once you have done that, you can search for this Groq API key. So this is like completely free for kind of development. So we have like enough calls that we can make. So go to this Groq API key in this Groq cloud. So once you're logged in, so this is what you would get in this API key section. If you haven't created any API calls before, so you won't see anything here. So these are the API keys that I've created for different projects. So now I'll kind of click here and create this API key, display the name. So let's say that I'm calling this as you know, YT YouTube route LLM key. You can just give a name to basically know like this key is for like which purpose. So you'll copy this key and paste it over here and say os.environ. You have to say Groq underscore API underscore key is equal to this. Okay, so this is how we have to pass your API key to the environment variable. So I'll run this. So you shouldn't change this particular name. So this should be constant because when you kind of call this Groq to load the model, to load that LLM's APIs, this is the environment variable that, the Groq library will kind of look at. So it should be the same. So all these letters should be in caps. So say Groq API key. And again, it's not a good practice to put your API key explicitly, or, open way in your code. So instead, you can put this in a config.json file, or you can also put this in a environment file. So you would have this .env, and in Python you have this load.env thing that you can use to load this environment variable, so that your key is not present in your code. So when I'm sharing this code, I'll just like remove this, and here you can replace it with your particular API key from Groq. So that is the next step. So here we have successfully saved the API key to this particular environment variable. So now in the similar way that we have kind of did the settings LLM Llama, so we have to say settings LLM Groq, and we have to use a particular model, right? So for this, I'll again come to Google and search for Groq models. And here it would have this supported models, and the supported models I'm going to use this Llama 3.18 billion instance, or again you can use this 70 billion versatile itself. But as is a simple use case, so I'll just like go with this one. So in this model section, give this LLM 3.8 billion instance. So basically what we are doing this so we have this settings kind of thing in Llama Index. So in that settings, we can kind of declare what's the LLM that I want to use. So in the settings.llm, I'm saying that I want to use Groq LLM, and you have to pass the name of the model. You can do this for custom models as well. If it's a Hugging Face model or a different model, you can load that here as well. And if you're using Ollama, similarly settings.llm, you have to say like I want to use Ollama and this is a particular model. So if you're using Gemma 2 billion, you should have already pulled it. So if you are, let's say, using, as I've shown earlier, so if you're using, let's say, a Llama model or a 5.3 model or something, you can mention those models here after pulling that. If you don't pull that model before, you will get a error over here. So this is the next step of declaring the Groq model. So I'll run this. So in the similar way, we have to declare what's the embedding model that we are going to use, because in several places it would use LLM or it would use embedding model. So we don't have to mention that every time. So instead we can configure that in this Llama Index settings. So here I'll say settings.embed model is equal to Hugging Face embedding that we have over here, and then copy and paste it over here. So this would download the Hugging Face embedding model. As you can see over here, you can ignore this warning. So it's not kind of a big deal, but yeah. So this is kind of importing this Hugging Face model. So we have successfully pulled in the embedding model from Hugging Face. So this is again the default model. I didn't mention any parameters, but let's say that you want a larger embedding model or a small embedding model, or any specific embedding model, you can mention that over here so that that particular model is pulled here. So far what we have did is we have read this document into text, stored it in the list, and then we have splitted it using this sentence splitter and stored this data in nodes. So we have created these text nodes, and then we are setting up our LLM and embedding model. So the next step, we have to set up our summary index and vector index. So these summary index or vector embeddings are the ones we kind of it when the user is asking a question, and then we retrieve the relevant information from that. So here I'll say from llama underscore index dot core import summary index. So S and I should be in caps, and then vector index. Sorry, vector store index. Okay, these are the two things. So summary index is basically used to work ideally in the case when you want to generate summary for some given text, which in this case the given text is the document's content. And vector store index is basically used for your RAG use cases where the user asks questions on the document, specific questions, not just asking for specific summaries and so on. So we have summary index where that would kind of look at all the nodes and try to build a proper summary, where vector index kind of looks for specific information related to the user's question. So these two are kind of used for specific questions. So you cannot ask a summary question on vector store index, because that would not give you an ideal response. I mean, it would give you, but the response wouldn't be ideal. Similarly, you cannot ask like pointed question in summary index. You can just expect like overall summaries and then basically the context of the document. So those questions are better answered in the case of summary index. So these are the two things that we need. So now I'll create a variable called as summary index and say summary underscore index is equal to this summary index. And here you need to pass the nodes. So nodes is basically what we have created over here using this a sentence splitter. So get nodes from document. So just like directly pass this nodes here. And similarly for vector index, you can say vector underscore index, and you can just copy and paste this vector store index over here and run this. So now we have summary index and vector index, and we can look for the summary index when we want a summary and vector index when we want to kind of answer a question. So now the next thing is we have to create this query engine. So I'll say summary query engine. So these can be separate use cases as well. So if you are working only on summary questions, again, you don't have to go with vector index. Or if you are working with vector index rack QA, you don't need the summary and so on. Our main goal is to, the user can ask any questions, but based on the question, we need to decide whether we need to use summary index or vector index. So for that, I'll say I want this summary query engine, and you can say summary index dot query engine. So this is going to query for your relevant information and give you what you need, and later that we would pass to the LLM and get a proper response. So say summary query engine, summary index dot query engine, and then in the response mode, we have like different ways in which we can create summaries. So here we can just mention this tree summaries. Again, there are different types of summaries that you can generate. You can refer to that and say use async is equal to true to use like asynchronous operation. This is for summary query engine. And then for vector query engine for document question answering, I'll say vector query engine is equal to vector index dot this should be as query engine, and run this. Oh, should be uppercase. Okay, so now we have summary query engine, and then we have vector query engine. So the next part is query engine tool. So these are like the kind of standard things that we need when we kind of build a RAG application in Llama Index. The steps are like kind of a bit different when you work with LangChain, but these are the steps when you're working with Llama Index. So I'll say from Llama Index core.tools import query engine tool. So I'll say summary tool is equal to query engine tool dot from defaults, and we have a parameter called as query engine is equal to summary query engine, and then mention the description. This is really important. So I'll say description is equal. I'll tell you why, but before that, let's say description is equal to in the you know you can just mention it over here. So I'll say useful for summarization related to the given context. So similarly, can just put this over here so that if I have a larger text, it can come in one line. We have to create a vector tool. So this is what document QA. So vector tool is equal to query engine from defaults. So here you have to pass your vector query engine to this vector tool. And here you can say useful for retrieval, or I can say retrieving specific context from the given context based on the given question. Okay, so these are the two things. So the reason I told you that description is important is the decision of whether a query engine, a summary query engine should be used or a vector query engine should be used. So that we kind of leave it to the LLM. So the LLM kind of looks at this and decide if the question is kind of the main purpose of the question is to kind of generate summary like answer. It would use this summary query engine. If it kind of as like specific questions where we need to extract specific context from the document, then it would kind of use this vector query engine. So this description is used or given to the model to make a decision of like which two tools that we have to use, whether you have to use a summary tool or you have to use a vector tool. So that the LLM is going to kind of decide. So the LLM is not just going to give you the answer, but it's also going to decide which tool is kind of needed for which specific question. So for that, I'll say from Llama Index. So the reason I told you was that this description should be very clear so that the LLM can kind of make that decision without any questions. And if you're using a smaller model, sometimes it can kind of won't be able to properly make that decision. Not in all cases, in some cases when these descriptions and the questions are not clear. So here I'll say llama index.core dot query engine dot router query engine import router query engine, and then I can say from llama underscore index dot core dot selectors import LLM single selector, which be a single queue. Okay, so here we have a router query engine. So that's going to route between the summary tool or the vector tool, and then you have LLM single selector. So you kind of call this LLM single selector. So that's going to choose whether to use this particular tool or this particular tool based on the user's question. It's okay if you're not kind of getting a part of that. So once we complete this, it would make like total sense. So in this next step after importing this, I'll say the final query engine that we are going to use is equal to the router query engine. So it's if you are using this vector tool, you can directly go ahead and use this vector tool or this vector query engine, but we want to route it. So we need to pass these two tools to this router query engine. So say router query engine, and the first parameter that we have to pass is the selector. So selector is equal to LLM single selector dot from underscore defaults, and then we have query engine underscore tools is equal to create a list and mention your tools. Again, you can have several tools. You can have similar to the summary and vector tool. You can also create some other tools as well. It's not just for these two use cases. So I'll say summary tool, and then I'll say vector tool, and then we need to say verbose is equal to true. Run this. Okay, so basically what we are doing is we are having this LLM single selector, and that's going to use the LLM that we have configured in our setting, which is the Groq LLM in this case. So what happens is when the user is asking a question, it's kind of gets sent to this LLM single selector, and after looking at this question, it would decide whether it should use this summary tool or vector tool. And this LLM knows that the purpose of summary tool is this. So this is given in the description. So it's kind of coded in such a way that it's kind of look at this description, make a decision whether a summary tool is used or a vector tool is used. So here you can say verbose is equal to true to, again, there would be a line that sends kind of why the LLM has kind of decided this question. So it would say that I've decided to go with this summary tool because the user's question is asking for a summary, or it would say this, I went with vector tool because it's a specific question or something like that. So in order to look at that particular intermediate, response, we need this verbose is equal to true. So I'll run this. And finally, we can kind of call this. So that is pretty much it. So finally, I can say response is equal to query underscore engine. Maybe I can copy it from here. So say query engine dot query, and within this, I'm going to say summarize the given document. Okay. Oh, this has become a text cell. So I'll change this to code. Okay. And finally, you can print this response. So I'll convert this to a string and print this response. Let's try without string conversion. Let's see how it looks like. Summarize the given document. So when I run this, it says selecting query engine 0. So query engine 0 is the first one. So this is my query engine 0 because this is the first one. So vector tool would be query engine 1. So it says the question is asking for a summary of the given document which matches the description in choice 1. So see, it's looking for the description. So choice 1 is summary tool. So it's using the selecting query engine 0, and it says the question is about the summary. Okay, so that's why I said these descriptions are like really important. So it says that a new approach to sequence transduction model has been proposed, which relies on self-attention span, which is basically the main crux of this particular attention is all you need model. So how this summary index would work is it kind of gets an idea by looking at all the nodes and it kinds of generates a summary, but you don't need that for vector tool for RAG QA because it's you just need to extract specific information related to that question, right? So we don't have to look at all the nodes. So similarly, I'm not changing anything. I'm just like changing the question, and I'm not telling the model that you have to use query engine 1 or query engine 2. So here I'll say what is the model architecture mentioned in the paper. So here we are asking specific questions. I mean, not so specific, but it is specific question. Let's see the model is able to make that choice properly. If not, we can change the question. Yeah, here you can say it says selecting query engine 1 and it says the question is asking for a specific piece of information, that is the model architecture from the given context, that is the paper, which matches option 2. Option 2 is vector tool and it's again looks at this description. So this description should be very precise and clear so that the LLM can make this choice. And you're seeing this pink color text over here, right? So this we are getting because we set this verbose is equal to true, and it's kind of really helpful to uh, basically understand why the LLM is making that choice. So you don't have to make anything, or you can also build a chatbot around this so that based on the user's question, the model can look at it and it can answer that. Right. So in the first case, we are asking for a summary, so it knows that it's a summary based question. So it's kind of using this query engine 1, and it's a specific context retrieval part like a RAG use case. Then it's kind of looking at option 2, which is the query engine 1 or your basically your vector tool. So this is how you can work with Route LLM so that based on the question, we can route the LLM to use specific tools. This is one example. So similarly, you have different routing concepts as well. So again, this is an interesting use case. You can explore this as well. So there are some cases or some questions that are very simple. So smaller LLMs can answer that. So for simple question, you can use a smaller LLM. For a bit complex question, you can use, let's say, a larger LLM. The main reason for doing this is to optimize the cost, right? So you don't have to ask simple questions to a larger LLM. A Gamma 2 billion model can answer that. You don't have to go with a Llama 70 billion model, right? So those are also other route LLM things that we can look at it. So this routing is based on the user's question, but that is based on the complexity of the question and so on. So in the upcoming videos, let's also understand how we can do that as well. But I hope this particular agenda is clear what we have done today. So I'll give you a quick recap of what's the purpose of this and how we have solved this from the start. So first we have kind of worked with this attention is all you need PDF paper, which is again a paper on transformers, and we know that the user can ask questions like summarize the given document, where we need to look at the entire document and give a concise summary, and then we have this option to use a RAG use case, which is to retrieve specific context based on user's content and then answer a question, right? So for this we'll be using Llama Index, and we have also enabled this list async pivot so that Llama Index runs a lot of asynchronous operations in the backend. So that's kind of enabled. And then we have simple directory reader. We have read all those document data content, just similarly what we would do in LangChain. So those are like pretty standard steps. So after we have read the content, we have stored this in the list called as documents, and then we have created this sentence splitter with the chunk size overlap and so on. Use this node text splitter and other stuff, and then we have set up our LLM. So we said like we want to use Groq LLM, and we have used this Hugging Face embedding. If you want to use Olama, you can just uncomment these two things and you can run it instead of this Groq. So make sure that you have saved this Groq AP key in your environment variable. And then we have loaded the embedding model. And then the important aspect is we have two indices. One is the summary index and the other one is vector store index. Summary index is used for creating summaries for your document, and vector index is for retrieving specific context, specific content from that context given by the user. And then we have summary query engine, vector query engine, and from this query engine we have created query engine tools, and we have mentioned the description so that the LLM can look at it and make a choice. And then we have router query engine that's going to route the LLM call based on the user's question. And again, how this routing is happens is also based on the LLM. So the first LLM decides whether it should use a query engine or a vector engine. So it uses either summary tool or vector tool, and then we can just go ahead and just use this query engine dot query, summarize a given document or ask specific questions. So I hope that everything what we have discussed today is clear to you. So please try this code and that would give you like a better understanding of this and as well a better practice, and you can think about what are all the complexities you can add here, and apart from this what are all the tools that you can use for this routing LLM thing. So I hope that this is useful to you. I'll see you in the next upload. Thanks for watching.